Hey, how are you guys doing? My name is Travis Simmons. I am a supplemental instructor for the GIS classes at the College of Coastal Georgia. Today we're going to be talking about running interpolations in QGIS. Uh, so let's first talk about what interpolations are. They're an estimation of a value in between other values, basically. So you're creating a surface out of where a surface wouldn't be originally. So if we look at this line on the left-hand side, this line of boxes and values in them, this is kind of what a raster format file would look like. And we've talked about in class where they're a big grid and they have values in them, but this is just like a line of one of those. So sit for a second and think about what that middle value would be there. So we got 30 on the outside, 20 on the next layer, 10, and then under that would be in between, in the very middle, what would that value be? So if we follow the trend, it would be, we're estimating that it would be 5. Now there's no rule that that should be 5, right? That could be any value in the world. But following the trend, we could estimate or interpolate that that would be 5. And this is pretty easy to do if you only have one row of values like this, right? But if you look on the right-hand side, with all these kind of patchy numbers, you got a 9, a 7, a 13, there's some high, some low, no clear pattern to them. If you wanted to try and fill in all those empty spots in those squares, there's no way you could do it, right? You can't just say, oh, it's probably this, probably that. You'll be all over the place. But there's a program, a script in QGIS that can do that for you. So that way you can figure out values in between other values where you don't have any values currently. So we're going to look at that today. The data set we're going to be using for this is the SOCM data set. So we got one float mapped up here. Got it already loaded in. And if you guys have any questions about how to download the SOCM data and get it to where you can put it in QGIS and get it displayed properly, let me know in the comments and I'll respond to them. If your QGIS looks a little different than mine, don't panic, that is fine. I'm going to show you how to get and set up all the tools you need to run the interpolations. I have a bunch of plugins and stuff loaded into my personal QGIS just because I do a bunch of random stuff with it. So don't worry about that. Okay, so first we're going to get our data set that we want to work with. Right now we have all these points, and if we press information right there so we can get some information on one of these points, there's all kind of data associated with each one of these points, right? Tons of measurements, right? And one of these, let's see if we can find it here, is depth, right? So this particular measurement that we clicked on was taken at 1,971 meters. So that's a super deep measurement, right? And if I wanted to do an interpolation, let's say of the salinity. So we have these salinity values, a ton of salinity values for each of these dots, right? We can click on another one and look at it. So just as much information there as the other one. Tons of measurements, right? But let's say if we wanted to see how, so we have a salinity measurement at this dot, and we have a salinity measurement at this dot. We wanted to know about the salinity in between those two dots. Currently, all the data we have is just these dots. There's nothing in between the data. If we wanted to put some data there and kind of estimate what the salinity would be, we can do that with interpolation. But first, we want to subsect our data to just contain the values that we care about. So if we had measurements from like right at surface level all the way down to the bottom of the ocean, we wouldn't want to run interpolation on that whole data set, which is what we have plotted here, because they're going to be highly variable, or might be highly variable through the water column. So first, let's just check out the surface level values. So to only pull the surface level values out of this, we're going to do something called a select by expression. So if you right click on your layer name there, then you open your attribute table. So this will contain all the attributes for all of your floats, which is a ton of them, right? A ton of values, right? And each one of these is going to have a depth associated with it. So let's see. So we have 71, 66, 61, whatever. So first, let's just select all the ones that have above a 100-meter depth. So we have a surface level measurements, okay? So we're going to go right here. This is the select by expression tool. So we're going to click it. And then we're going to select, we're going to find depth. So we're going to search for just depth. And this field will pop up for whatever you named your depth in your CSVs when you're cleaning your data after you downloaded it. So if you just double click that, it'll add it into this little editor here. And then we can just type, we want all the depths that are less than 100. So that will select all the measurements in this entire data set that have a depth that is less than 100. So we can go to here and select features. All right, and we can exit out of there. And we can see in the background there, well, it went away now, but there was 380 features selected, and we can see here that, you know, we got a lot of them selected throughout these. And if we scroll through here, see all these have a depth less than 100, so that's awesome. Looked like it worked fine. So we have these selected now. So we can minimize this. We're going to right-click our layer name again, and then we're going to go to Export, Save Selected Features As. So this is going to take out the features we just selected and then put them in another layer. So we'll have a layer of just those guys. All right, and then we're going to name it Surface. You can name it whatever you want. Probably when you actually go to do your analysis, you're going to want to put your float name in there and then say Surface, but right now we're just, for the sake of simplicity, we'll do that. All right, and see, it said it was exported, and we got a new layer here called Surface. It looks like, you know, nothing changed here, but that's because each of these measurements, these dots, are going to have a measurement above 100 meters. I mean, yeah, more surface than 100 meters. So it's not going to look like it visually changes any if we take off the one we just, if we unvisualize or hide the one we just created. It's not, you know, you're not going to see any difference, but that's okay. Oops. All right, so now we have a layer that's only the points we want to interpolate or get the values in between of. And then you can do this for any parameter. You can do salinity, you can do oxygen, you can do particulate organic carbon, you can do, you know, chlorophyll, all kind of stuff, right? So now we need to go up to processing, then hit toolbox. Now this toolbox is super powerful because this is like all the tools that QGIS has. You can do all kind of analysis with it and mess with it in all kind of different ways. But we're looking for interpolation, which is right here. So we're going to click the little arrow next to it to bring down all the options we have. Then we're going to do an IDW interpolation, which there's other types of interpolation. Feel free to research them and, you know, use them appropriately if you like. But IDW interpolation is kind of just like the one we're going to be using for this class. So we can double click it. Okay, so then this interpolation menu will come up, and we're going to choose a layer we want to interpolate. So it automatically chose surface for us, probably because it's the first layer. But if for some reason it came up with a different one, you can click here and then choose whichever layer you want to interpolate. All right, and then you're going to choose which attribute of that layer you want to find all those missing values for. So let's try, let's see, we can pick any one here. Let's go salinity. And then we're going to add it with this little plus button. So this is going to be our interpolation, and it's a point file, so that's good. Then we're going to come down here to where it says extent and do the little dot, dot, dot. And then we're going to use select extent on canvas. Then we're going to take our little cursor here. It brings up this little plus marker, and we're just going to drag across and select just the area we want to interpolate. Because since we're creating a new surface, we can't just interpolate the whole thing because right now there's no values there. So we got to select what area we want to create a surface on and plot those kind of estimated values. So we got that. We're going to pull it up a little bit so we can see the bottom. If you wanted to name this file something special, you could put the name right there. I'm just going to leave it. Actually, I'll do salinity underscore interpolation. Sweet. Then we can hit run. Dent files not supported for this algorithm. Okay, we'll turn off the name for now. So just run. And depending on how big of an area and how many values you have, that could take much longer than that just took. So if your computer is just like freaking out sitting there for a second, leave a comment. We can fix that as well. Generally, what you're going to have to do is mess around with these parameters, the pixel size parameters right there. If you can make it, you can crank it up as high as you'd like. Try running it again. But anyway, usually it'd be fine. It might take a few minutes. I think the longest I've ever had one take is like 15 minutes when I had a really big extent that I wanted to interpolate. So if we go ahead and close this, you can see we now have this really cool looking dot here. I mean, not dot, map, interpolation. So what this did basically was take those values that were on the floats. Let's move the floats on top of this so you can see them. All right, so it took the values from each of these floats, each of these measurements that we selected, and so like if it was higher in one of these lighter regions, right, and then it guessed in between those regions what the salinity value would be, and then it gave it a pixel intensity value, so it was like, you know, lighter if there was more of that value there. And then these over here clearly had lower salinities, and so it kind of guessed at all the values in between that. And then it comes up with this pretty visual. You see where like in this area it had a lower salinity, and this one it had a higher salinity. And it gives you that gradient so you can kind of talk about in your paper about, you know, oh, well, this area had less salt in it, this one had more salt in it, whatever, yada, yada, yada. And of course, there's a bunch of different considerations that you have to make before you can just say, you know, this area has more salt in it, whatever. We can talk about that in class if you guys like, or in my SI sessions or whatever you want to do. And then one thing you can do to make this a little more visually appealing and make it look a little more clean is you can double click your interpolated layer, and then you can go over to symbology if it doesn't automatically go to it. Change the render type to single band pseudo color, and then you can pick from this drop down right here the color ramp you want to use. I'm going to use the blue, and so based on what value it's guessing that pixel has for salinity, it's going to give it a different color, with the darker being a higher value. So it goes from 34.05 to 34.18. So we don't have a very large range of values for this one. So you'd have to be careful that, you know, if we look at this picture, here, let me run this and then we can talk about them. So if we look at this picture, now like the darker ones are going to be the higher in salinity. But as we saw, those values are less than one unit off, right? So this could create a false picture that, you know, right now it looks like there's a lot more salt over here than there is over here, when in reality there's only 1 unit difference. So, you know, you can talk about that in your paper. There's lots you can do, but this is how you run an interpolation in QGIS. You could take a screenshot of this and add it to your paper, or you can export this layer and let's see this. Yep, so you export it and then save this layer, and then you can save it as a TIFF. That's going to give it georeferencing, or you can save it as, no, I'd save it as a geotiff. So geotiff, then you can name it right here, blah, 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 and then save it, and then you'll have a picture of your interpolation. So that's all, you guys. Yell at me on the discussion board or on here if you have any questions about how to do it. If your points aren't lining up, no matter what, just, you know, reach out and I'll help you. You guys have a good rest of your weekend. Bye.